Okay. This is a video about why you should have four-way light switches in your master suite. Basically, the answer is security. And this is the wiring diagram for Villa Cecilia. We have 6 sets of 3- and 4-way switches. Each one of the sets contains 10 lights. This building is a decagon shape. That's a 10-sided geometric figure. So around the outside you have 10 double bulb security floodlights, and then there's several rings inside the house in the atrium and underneath the catwalk and different places. And if you had a security problem at night when you were locked in your master suite, it might be nice to be able to turn on the lights and see what's going on out there. So that's why we put one set of switches in the master bedroom. There's a set of switches at the top of the helical stairs, and that's pretty much if somebody's on the second level and wants to turn a bunch of lights off, like the ring around the lanais out there, they have lights, and you can turn them off without going downstairs and coming back up in the dark. Well, there's LED lights on the stairs, and then there's a set on the opposite side of the house on the living floor, and that's in the kitchen or the pantry. I'm not sure which we're gonna call which room right now. So this is a diagram. Let's see if we can zoom in on. Okay. Oh, we'll look at something right here and come up. Each of these light bulbs here goes to a different one of these black wire rings up here. A 3- and 4-way switch set turns on each of these tracks. You can turn on any one or turn off any one. There's a ground side which is all connected together for all the lights. You're only going to switch the power side. And this is drawn with for one of the 10 segments of the house. But in actuality, you could we will have a group of light bulbs like this on all 10 segments. Anything that's on wire 13, no matter what you hook to it, will come on with track 13. Same thing with 14, 15, 16, 17, and 18. So since we have, like for instance, the security lights on the living level around the outside of the house, each one will come into a sub panel basically for that segment. So there will be a light on 10 places. There will be a light hooked to 13. You can hook other things to a track, or you can emit things from a track. Okay, now it's go down here, look at the bottom a little bit. Okay, there's a bunch of red lights here, sort of dead-ended. This is the power for the switches. You'd pick up the, if it was 110, your white wire would be any white wire in the house. Any place you are, you have a white wire. But we're going to have it 220, so we're going to run the same side of the 220 to each of these. We're putting a separate fuse on each track, a circuit breaker. We don't use fuses, circuit breaker, so that you can turn off any track, or if there's a problem with the track, it doesn't affect the other ones. But this would go to a circuit breaker, but rather than confuse the drawing, that's the only wire really that's not on the whole drawing, is the one it comes from. Why won't you drag? Okay. Up here in the sort of the upper right, that's the wires this looks at coming in, and they come over, and you know they're all running together. They're all in the same pipe basically. And you come down a little bit. Here's our first set of three-way switches. The three-way switches is like a garden gate. It's either open or it's closed. Like we have a switch here. This is the power all coming in. You either flip it this way or you flip it that way, and that determines whether it's coming out on 9 or 10 in this case. And that's all a three-way switch is. It's a choice. Power always comes out of something. Power, if there's power coming in, it will come out on one of the other two. There's not an off position on this switch. It's always going somewhere. Okay. And we have these blocks in here. What these blocks are is so we don't have to have a bunch of wires put together with B caps. You know, the red plastic caps you screw on. And the smaller ones are yellow, then orange, then blue. The color tells you what number of wires goes in them. Those tend to be a rat's nest. It looks like, you know, like seaweed on the beach, and you can't follow it. So what we use is it's like little terminal blocks, and the connectors have a screw that bears down on the wire, and there's a screw on each side of the terminal block. So you come in on one side and go out on the other. And so you don't crush the wire, it's got what they call tubular screw. It pulls three sides of a box up against the other side of the box. That's just how it works. Okay, so we're going to go here and look a little farther back. You can count these orange blocks going around here. There'll be 10 of them, because each room in the house has a small sub-breaker panel. You know, you have an electrical room with the main breakers, but rather than run a bunch of wires back to the electrical room, which would be a tremendous amount of wire, you know, to come from a room over here all the way around to the electrical room over there, I don't know, it's 120 feet of wire for one strand. So if you keep all your wiring for one room in a circuit breaker box, the only thing that runs back to the electrical room would be the red and a black for the 220, green for the bond wire, and a white for a possible 110 if you ever wanted to hook something to 110 and actually had 110. Anyway, we've come through a set of switches, three-way switches down here at the bottom. I gotta make sure it's on the screen. I'm wiggling this mouse and it's over someplace else. But that has come over here from the three-way switches. It's come over and down, and now we get to the four-way switches. So you're coming in over here, you're coming down, and this is 3 of the switches, and then there's 3 more over here. You see this? These wires are coming in. The ones up here on the right half, those 6 wires went in here. The other ones went across to these 3 switches over there. There's a note on this diagram about this bunch of checkerboard stuff here. This is easier to hook it up than it is to explain, but we're going to explain it best we can. This is a note that shows you that these wires are crossing over. They're not connected. That's what the little round thing means. It means this wire jumps over that wire and this wire and this wire, right on down until it comes out the other side. It's a pass-through. This wire shows wires crossing over each other but not connected. That's only on one place on this drawing. The drawing is made to have minimum amount of confusion. I don't know how successful that is. Anyway, we come to our 4-way switches. We come around. Now, if this was a rectangular house, it just wouldn't be a curve. you'd have a wiring pool box or fuse box or whatever you have. Any place you wanted to put a bunch of odd switches and you want to connect stuff up and put individual breakers so you didn't have to run home runs. The other choice is a more standard kind of wiring where they take and run a breaker into a room and hook just about everything to it. And if you have a wall receptacle goes out, a lot of times your lights are hooked to the same wire. You can't plug a light into a receptacle because they're the problem. And you can't use the light in the room to see what you're doing. You have to start running extension cords from somewhere in the house that's not on that breaker. But that's a way they do it. I don't particularly ever do it that way, but you can do it that way. It's cheaper. This is more expensive. But our house is fairly complicated. So for us, it was a way that we could get all our 3 and 4-way switches. But like I say, this is a round track. It goes around and it ends. It started here, went through all the switches, come around, and there's an end. It's not connected across there. This is the other set of the 3-way switches over here. When they come out of that set of 3-way switches up here at the top, that's what powers those black rings. The power that came in down here going to the first 3-way switches came around through the 4-ways, to another set of 3-ways and out. Now, 3-way switches are like garden gates. 4-way switches are a different animal. Let's see if we can get one here. 4-way switches are a crisscross. This bar is showing like there's 2 bars because that's the way they draw them. But really there's only 1 bar. It either flips to connect these 2 or it's flipped the other way, connects those 2. But there's only really 1 bar in the switch, the physical switch. It gives you a choice. What comes in here can either go out there or this one can come out there. Depends on which one was hot from your 3-way switch. If you have multiple switches, like if you want to add another switch someplace, the ends have to be 3-way switches. You can't use a 4-way. Won't work. The ones in the middle can't be a 3-way. They got to be 4-way. If I wanted to have another 4-way switch here, all I'd do is just break into those 2 wires and put the 4-way switch. If I wanted to put a switch over here, somewhere past the 3-way switches, then I've got to change that 3-way switch to a 4-way switch because all the ones between the 3s have to be 4s. And there would be a 4-way here and 4-way wherever your last 3-way was. And then you'd have a 3-way on the next place past that where you want to add a switch. I think that's pretty much how this works. It's circular because our house is circular. But these individual wiring groups of 3-ways and 4-ways, see, there's the same kind of 3-way the other one was. And you see here's when they come out of the last 3-way, then they go out and feed the tracks. That's another orange block, come from eBay. They're not very expensive. Okay, there's a lot of notes on this thing. It's just telling you how we chose the colors on that. We call them orange blocks because that's the color of the plastic they are. In that same panel, we have 2 other kinds of blocks. The major one that most people don't have is the bond block. There's a green wire to everything. Everything in the system has got a green wire run to it. I don't care if it's an all plastic, double insulated, whatever. The green wires are run because they're required by code. Some places there's no place to hook them, but you have to have them in the pipe. The white wires are run because my Asawa has a bunch of 110 volt this and that. She collects things like that, and we have a bus bar. A bus bar is a way to connect a lot of wires. They're all really basically the same. It's got a little bit bigger holes in it, but it's a solid piece of brass. You got screws along it that bear down on the wires, and anything you put into one of the holes along that brass bar is connected. It's very neat, but you can't connect, you cannot legally connect a bus bar with the white wires with the bus bar with the green wires. The green wires are safety bonds, and the white wires are the neutral of your 110. When you get back to the circuit breaker box in the Philippines, when they passed a law in the electrical code that you had to have bond wires and all those things, the manufacturers took the ground bars out of the enclosures. They're not in them anymore. They when you're looking for them, they say, "Oh, that's the old obsolete ones. We don't have anymore. We sold them out." But if you want to hook up the stuff by code, then you have to go to OLX, eBay, Lazada. I got the last bunch through Lazada. They didn't have them last year when I was trying to get them, but now the electrical code requires them. So somehow somebody's selling them there. Anyway, we have our orange blocks mounted on a metal standoff to the concrete, and the concrete is pretty much non-conducting. So we have a bus bar for the green wires on one of the standoffs, and the other one has a standoff, but it's for the white wires. What else is there? Oh, there's actually 2 orange blocks in every box. You have wires coming in that would go down to a 3-way switch. When they come back from the 3-way switch, they go to another one that's sort of an outbound kind of orange block, because you connected both sides of the incoming orange block, the ones coming in, and then when they left there, they went to the 3-way or 4-way switch. So when they came back, they can't go to the same place they came from. Switch wouldn't do anything. So they go to another orange block. So we have 2 orange blocks in each of these sub panels, and they're mounted on standoffs. And on the standoffs, you have the green wires on one standoff and the whites on the other one. Now you can use insulated mounts on your ground bars. They tend to be expensive. They cost a lot more than the ground bar. It's a stud with a chunk of plastic in the middle and metal threaded things out both ends. And you bolt one end to anything, side of the box or whatever. And when you bolt your ground lug to the other one, and it's electrically isolated. But everything that's put in through the holes in that ground bar is connected. It's really neat. And we use wire numbers. This diagram has got wire numbers. I don't know if they're on absolutely everything. I know where they're connected, there's wire numbers. Yeah, they're everywhere. 1 through 12 is all your, what do they call the runner wires? Travelers. That's the travelers for the 3- and 4-way switches. It takes 2 wires for each switch. So we have 6 sets of 3-way and 4-way switches, so that's 12 wires. And down here, the black ring, which is not on the camera screen. Yeah. That's the wire numbers for the ones you hook all your lights to. And of course, the one side is all on a common wire here. Well, these ones are the ones going to the rings. This is going out to the commons. I don't know what you call a common on a 220. It's just the other leg of the 220. The breaker has 2 wires coming out of it. One wire is feeding all the stuff that ends up coming to here, and the other wire makes it into a 220. So they're all collected together. And because you have 220 in all your sub panels, just take a voltmeter and find out which one your wire to your light bulb is, and the other one goes to the other side of the light bulb. It's no more complicated than that. Ours is we went by in checked that the same polarity was on the top of every breaker leaving the electrical room is the same voltage as the main breakers. We actually have main breakers in the panels, and then they go down to the breakers. Most of the ones you'll see in the Philippines, I don't care how many, if you buy a 20 breaker panel, we still won't have a main breaker. What you do is you take and put a large breaker at the top, either side, a 220 breaker, like you put a 60 or 100 amp breaker, and you run the electric through it backwards. It's AC, it doesn't care. You can do that. It's just a matter of the bus bars where that breaker connects, is it able to carry 100 amps on that one bus bar? I don't know that when you have a main breaker that's up above it and comes down to feed 2 copper bars, whether the bars are bigger or not. I would think not. But anyway, what you end up doing here is, unless you import like a Westinghouse or General Electric breaker box, which has ground lugs for both, and in the U.S. they connect them together. Can't figure out why. It's 2 different things. But there's a grounding strap that goes from one to the other in the bottom of the box. And if you don't want to connect it there, you take that part out and throw it in the bottom of the box. If you want them connected, you just, it's bolted on when you buy it. So just leave it alone. And like I said, if you had a 6-room house, you may not have small breaker panels in 6 rooms, because they're connected to each other, and depends on how far it is to the farthest run from your main electrical service. On us, the house is 65 feet across, and we have to go around the atrium. Now, this is a big open hole in the house here. It's 27 or 28 feet. It's got a catwalk around it, and we're putting an 8-meter fan. The blades are 8 meter across. Well, the hole's 8 meter. There's a molding goes on it, and then some clearance so people can't put their hand in it. So it's really about a 7-meter blade sweep. But that's to send air up through the house. It goes out through some roof vents, radial vents on the roof. So there's no air conditioning. The natural draft of the house will blow papers off the workbench on the upper floor just on a regular day. And if this fan was on, there'd be a serious amount of air coming up. And it's designed so that all the sections out here are boosters, basically. They speed the air when it comes from the bigger trapped area through a round 37-inch window. So when it comes through there, if it's 1/6 the area of what comes in, it's going 6 times as fast. What goes in got to come out, or else the pressure would build up and be like a scuba tank very shortly. I don't know if anybody's interested in doing something like this or not, but what we're going to do is we're going to put on the screen all the instructions here of how this needs to be done. And if you're actually interested in it, you can pause the screen and read it, or you can snapshot the screen. That's just showing you that those incoming wires, that note shows you that those are the power wires coming into the system. It's got its own little note clear up here. Nowhere's near it. I don't know if we've looked at this one or not. Oh, this first note here. Electrical code does not allow crimped, does not allow soldered only connectors. You can't put a solder on terminal end so that it'll fit into your receptacle. There's 2 kinds of receptacles. One, you wrap the wire around a screw, and the other one, you poke them in the back. The ones you wrap around the screw, they're the devil of a thing to get them, all the little strands of wire actually under the screw. There's always a few strays hanging out, or trying to get over and short against something else. And if you put them in the back, if they rate this wall receptacles for like 15 amps, but you're in the Philippines and you want to run a number 12 wire there for hook up a blender or a toaster or whatever on your, the backsplash in your kitchen. Number 12 won't go into that. And then it's just a piece of metal that's pretty, well, it's thin, but it's spring loaded sort of. And when you push it in there, it pushes that out of the way, and what pressure it takes to bend that little tab is what the connection pressure you have on the wire. I'm not saying they don't work, just leaves me ill at ease. And then the green lug on your receptacles, which you really need to have, you need to hook that up. That's a screw that you have to put something around. And what I choose is, I don't like crimped only, which are legal. I've had them come off. I ride big, fast motorcycles. I mean, fast motorcycles. We're not talking 150 mile an hour. We're talking fast motorcycles. And I rode one into Kings Creek at about 30 miles an hour one night. It was a 736 Royal Enfield. Not a real fast bike, but it's a great bike. Anyway, I had one of those things fall off on the headlight, and I was used to being looking in a light, and all of a sudden this pitch black, couldn't see a thing. I turned when I thought the turn came up. I was late. First thing I felt was brush. Next thing was water. And I soaked the bike down. Wasn't mine. A guy owed me money, and I had taken it in for work, and my bike was trapped behind other customers' bikes, and I didn't want to put them all in the parking lot to get it out. Then come back at 2 in the morning and have to roll them all out there again and put it back. So Rick's bike was next to the door, and I just, I knew it was in good shape. I just gone through most of it. But the wiring, I hadn't gone through it. I did the engine, transmission, clutch, all that. Respoked the wheels, tires. Just sort of overhauled it, but not the wiring. And that thing came off. And I've not used a crimped terminal on a vehicle since. But I like to solder on ones, but they won't let me do that here. So I have a tool that swages the terminals onto the wire, and then I solder it anyway. You get a real good electrical connection with the solder. Oh, we're off and onto. That says go down and find another screen full of text. If you're going to look at a drawing, maybe look at the drawing. All these wire numbers are the same. This is 1 through 12. And I don't know why it's written down that there's what panel they're in, because they're all identical. I guess it's just to make an actual wiring diagram out of all this. What was I headed for? Let's see, here's something over here we didn't look at. It's harder to do than you think. You're looking at the computer screen, and then you have to see what's actually shown on the camera. A lot of these were notes for the electrician. This is a circuit breaker that's in the sub panel. The sub panel, we used I think General Electric circuit breakers, but the panels manufacturer is a Philippine-made one called American, and it worked all right, and they were cheap. They were like where we first saw them, they were 536 pesos. I said, well, when we get around to that in a month or so, we're going to come get a bunch of these. And when we went around to buy them, we looked at a different hardware store, one we do a lot of business with, and they discounted them about 10%. So there was no reason not to use them. This is just a an average light hookup, nothing special. This is something where you're not necessarily going through the tracks here. All the wiring is on additional holes that are in the terminal block. This terminal block is isolated. Each wire is isolated from the one next to it. So this is a sort of a standalone light. And for some reason that's on the electrical diagram for the three-way switches. And it tells you where they go in the house. Hey, there's a little T. Isn't that cute? This is sort of a representation of the different lighting locations. These on the side over here, those are the outer security lights. These are the upstairs, the non-living areas. It's really a fan housing that's 8 feet tall. It looks like rooms, but it's not rooms. There's a ring of lights around that because it's a roof that you can walk on. And the lanais are out off of that roof, so you need lights in case you do go up there. It's higher than the mosquitoes fly, so it's kind of handy in the evenings. This is our atrium here. These are the sub panels in the posts that come up to hold up that roof. And this is a ring of lights around the outside. There's a ring of this is the actual outer roof. There's an inner smaller circle. It's the roof over top of these this spider beam. So this is the No, this is the roof that's over the spider beam because the leg's in there. The atrium is smaller. It's only about to here. So this light is on that shelf between the top of the around the atrium. It's another, like, basically a floor up there. People sleep in there. It's a terrible wind through there in the night. Anyway, this is a light that's in the spoke.